Welcome to the DIY Honda Garage channel. This slide presents an overview of DTC P0420, which signifies a malfunction in the rear bank catalyst system efficiency, specifically for Bank 1 of the Honda Accord models from 2012 to 2017. This diagnostic trouble code indicates that the rear warm-up three-way catalytic converter, referred to as WU-TWC, is not effectively converting harmful exhaust emissions into less harmful substances. The main pollutants it deals with include hydrocarbons, HC, carbon monoxide, CO, and oxides of nitrogen, NOx. Upon detecting a performance drop, the Powertrain Control Module, PCM, initiates an air-fuel ratio adjustment, monitoring the fluctuations via the secondary heated oxygen sensor located at the rear exhaust section. When the performance parameters exceed predefined thresholds, the PCM stores the DTC and alerts the driver that further investigation is necessary. Proper understanding of this code is crucial for efficient repair and maintenance of the vehicle's exhaust system. In this final troubleshooting step, the technician must set the vehicle's cruise control to maintain a speed of exactly 55 miles per hour for at least 68 seconds. This criterion allows for stable conditions to closely observe the behavior of the exhaust system. By cruising at a consistent speed, the secondary heated oxygen sensor, HO2S, can relay information about how effectively the rear WU-TWC and exhaust system are functioning without introducing variable elements from fluctuating speeds. It's paramount to ensure that other environmental conditions are favorable, providing the most accurate data possible. If the system is reset by disconnecting the battery, extending the duration to 4 minutes is advised to gather ample data. Ultimately, this controlled environment aims to capture the last diagnostic details essential for determining if further repairs are necessary. Following the troubleshooting process for DTC P0420, it is essential to carry out final repair verification. Start by ensuring that no diagnostic trouble codes, DTCs, remain stored within the PCM after any repairs have been made. To confirm that everything is functioning correctly, a road test is necessary. During this test, the technician should verify that the check engine light, MIL, remains off, indicating that the issue has been resolved. It's advisable to monitor the vehicle under typical operating conditions to ensure that no symptoms reappear, thus providing assurance that the repairs were successful. This final step of verifying repairs is critical to ensuring that the vehicle returns to optimal operational status and complies with emissions regulations. Only after passing this phase can we consider the vehicle thoroughly repaired. To prevent the occurrence of DTC P0420 in the future, implementing a robust preventive maintenance schedule is vital. Regular inspections of the exhaust system should be conducted to identify any signs of wear, rust, or damage that could compromise performance. Monitoring the functionality of oxygen sensors, particularly the secondary heated oxygen sensor, is also essential, as any irregularities in their readings can indicate potential issues with the catalytic converter. It's wise to replace any components that are showing signs of deterioration proactively, thus preventing failures before they arise. Consistent maintenance helps uphold the vehicle's emission standards, enhances engine performance, and can yield long-term savings by avoiding costly repairs resulting from unresolved issues. Educating the vehicle owner on adhering to these practices can significantly benefit the longevity of key exhaust components. In conclusion, understanding DTC P0420 and the implications of catalytic converter performance is paramount for maintaining an efficient and compliant Honda Accord from 2012 to 2017. The catalytic converter plays a vital role in reducing emissions and ensuring that the vehicle adheres to environmental standards, thus preserving air quality. Following the recommended diagnostic steps in a systematic manner ensures that technicians can efficiently pinpoint the root of the problem. Addressing the possible causes, symptoms, and executing thorough troubleshooting steps not only aids in the effective repair of the vehicle, but also fosters a better understanding of overall vehicle functionality. Finally, emphasizing a preventive maintenance approach can further enhance the driving experience while mitigating the risk of future occurrences of the DTC, benefiting both the vehicle owner and the environment. DTC P0420 addresses the performance of the rear warm-up three-way catalytic converter, WUTWC, located in the vehicle's exhaust system, specifically on Bank 1. This component is essential for the reduction of harmful emissions, transforming hydrocarbons, carbon monoxide, and nitrogen oxides into water vapor, carbon dioxide, and dinitrogen. Positioned after the engine exhaust manifold, the WUTWC ensures optimal vehicle emission performance. The PCM plays a crucial role in regulating the stoichiometric air-fuel ratio for combustion efficiency, while simultaneously monitoring the secondary heated oxygen sensor, secondary HO2S, to evaluate catalytic performance. If the system detects inefficiencies or malfunctions in the rear WUTWC's operation, the PCM stores the DTC, alerting the vehicle owner that repairs or replacements are needed. In summary, understanding the role and location of these components is key to diagnosing the DTC. When diagnosing DTC P0420, several factors may contribute to the issue. Firstly, deterioration of the rear WUTWC is a primary suspect, as catalytic converters can degrade over time due to heat cycles and exposure to exhaust gases, leading to reduced efficiency. Second, electrical noise in the rear secondary heated oxygen sensor, Bank 1, Sensor 2, could interfere with the output signals sent to the PCM, impacting detection accuracy. Next, a loose connection at the HO2S connector can cause intermittent readings or a complete failure of communication with the PCM, mimicking the symptoms of a failing catalytic converter. Additionally, modifications to the exhaust system that deviate from factory specifications may cause imbalances in exhaust flow or sensor readings, compounding the diagnostic challenges. Understanding these potential causes sets the groundwork for effective troubleshooting. Symptoms associated with DTC P0420 can significantly impact the driving experience and overall vehicle performance. The most common symptom is the illumination of the check engine light, MIL, indicating that an issue has been detected by the PCM. Drivers may also notice a decline in engine performance, with sluggish acceleration or difficulty maintaining vehicle speed due to improper fuel combustion because of the failing catalytic converter. Moreover, increased emissions are a crucial concern, as the faulty WUTWC will not adequately convert harmful exhaust gases, potentially affecting vehicle inspections or emissions tests. Understanding these symptoms aids technicians in quickly identifying and addressing the underlying issues related to this DTC, ensuring that emissions meet regulatory standards and maintaining optimal vehicle performance. The first troubleshooting step involves starting the engine and holding the engine speed at 3,000 RPM without load until the radiator fan activates. This process allows the engine to reach optimal operating conditions, which is crucial for accurate diagnostic testing. After the radiator fan engages, the engine should be allowed to idle, ensuring that the necessary components reach their operating temperatures. This method is intended to simulate conditions under which the catalyst operates efficiently. thus providing a solid foundation for the diagnostic process. Carefully monitoring the engine's behavior during this step offers insights into the underlying performance issues that may be impacting the catalytic converter's efficiency. In the second troubleshooting step, the technician is instructed to drive the vehicle at a speed between 45 and 75 miles per hour, maintaining this speed for at least 5 minutes. This step is essential for adequately warming up the rear TWC, as catalytic converters require a specific temperature range to function effectively. The extended driving time in this speed range promotes thermal efficiency and allows for accurate monitoring of the exhaust emissions. A warm catalytic converter performs optimally, facilitating the conversion of exhaust gases while providing the PCM with accurate input from the secondary HO2S. Successfully conducting this step is critical for determining any persistent issues affecting catalytic efficiency and assessing the overall integrity of the exhaust system components. During the third troubleshooting step, the technician should drive at a constant speed between 55 and 75 miles per hour for a minimum of 10 seconds. This action allows for consistent exhaust flow through the rear TWC, while also enabling the secondary heated oxygen sensor, HO2S, to monitor exhaust composition accurately. Maintaining a steady speed minimizes fluctuations that could confound diagnostics, strengthening the reliability of the data gathered. The results recorded during this segment help the PCM evaluate the catalyst's performance under stable conditions, showcasing how well the system performs outside of load variance scenarios. Monitoring parameters during this phase is essential for diagnosing the vehicle's emissions capabilities and for determining if further investigation is warranted. In the fourth step, the technician should decelerate the vehicle with the throttle valve completely closed. This step is imperative as it allows the PCM to analyze how the engine and exhaust system respond under reduced load conditions. During a closed throttle deceleration, the exhaust flow dynamics change, offering a distinct view of how well the oxidizer is functioning within the TWC. Observing secondary HO2S readings at this moment is crucial. Any unexpected deviations could indicate a problem with catalyst functionality. Because this condition simulates a critical operational scenario for the exhaust system, it provides vital information regarding the status of the catalytic converter and overall performance under various driving conditions. As the fifth troubleshooting step, technicians must repeat the driving pattern established in steps 3 and 4, completing this cycle 5 times. This repetition is key to strengthening the diagnostic results, as any intermittent faults may become more evident through increased data collection. Each cycle contributes vital information about how the vehicle systems perform under the same conditions. This step also allows the PCM to better establish an understanding of the catalytic converter's reliability. It is important to document any anomalies observed during each iteration, thus compiling a thorough diagnostic report for further analysis. Consistency and attention to detail during this phase are crucial for identifying underlying issues affecting catalytic efficiency. Please like and subscribe to the channel. See you next time.